Okay, so for this first one, okay, like we said, anytime we do a mole equation question, the first thing we want to do is write down what the question gives us. Okay, first thing the question gives us is it asks us how many moles. So one of our givens is, here's what you're looking for. We're looking for the number of moles, so we're looking for N. Okay. Then it tells us that the material we're dealing with is carbon dioxide. That can help us to calculate molar mass. All right, so carbon dioxide is CO2. Okay, got to get the formula right or I won't get the molar mass correct. Okay, so I'm going to have 12.01 plus 16 times 2, which should be 44.01 grams per mole. Okay, for my molar mass. Okay, and then the last thing they tell us is the mass, 150 grams. Okay, how do I know which thing is which when I'm writing down my givens here? How do I tell which thing is N and which thing is M? I look at the units. Okay, if it says how many moles, moles is always N. Okay, I know I'm looking for N, or if it tells me you have this many moles, I know that's N. Okay, I look for the units, right? If they tell me something in grams, I know that's little m. Okay, I just look at the units and then I know which thing it's giving me and I can write it down in my givens. Okay, remember that on a quiz or a test, you get a mark for this step. Okay, all right, so they want to know how many moles, so then the next thing I do is I write the mole equation. Okay, it's already set up to solve for moles, so I don't have to move anything around. Okay, I don't need Avogadro's number for this one because it's not asking or giving me molecules, so I don't have to worry about that step. Okay, I just need to plug in 150 grams divided by 44.01 grams per mole. Okay, that'll give me N. So 150 divided by 44.01. All right, so we're looking at 3.41 moles. Okay, questions on how that one worked? Okay, don't be afraid to ask, guys, if you got questions. All right. Okay. I want you guys to try that one. Okay. This time they're asking you to find the mass of a given number of moles, this time 26.5 moles, of cobalt-2 bromide. Okay, I'll give you a few minutes to get ahead of me there. Okay, so on this one here, okay, it's asking us, what is the mass? Okay, mass is little m, so that's what we're looking for. Okay, they're telling us 26.5 moles, so they're giving me N, 26.5 moles, and they're telling me that it's cobalt-2 bromide. So here's cobalt, here's bromine. What does the Roman numeral tell me again? Right, that the charge is 2. Okay, not that the number is 2, the charge is 2. Okay, and that's what I'm going to use to drop and swap this compound. Bromine's a -1, so I'm going to be COBr2. Okay, really important that we remember that. All right, now that I've got that, now I can get my molar mass. Cobalt is 58.93. Okay, there's only one cobalt, so we only need one there. Okay, and then there's 2 bromines, so that'll be 79.9 times 2. 58.93 plus 79.9 times 2. All right, so we're looking at 218.73 grams per mole. All right, so I need to find little m. So the mole equation looks like this. N equals little m over big M. I need to get little m by itself. So if I want to move big M, I do the opposite operation. I'm dividing by m right now, so I multiply by m. Then what I do to one side, I do to the other, and now I've got my manipulation done, and now I can solve for mass. Okay, so mass will be, okay, big M, 218.73 times 26.5. Okay, if you're wanting a more logical way to think about what we're doing mathematically here, okay, remember that this number is the mass of 1 mole, and this is how many moles I have. Multiplying the two will tell me how much that all has in terms of mass. Okay? Everybody follow me there? Okay, so we're going to take that and we're going to multiply by 26.5. All right, so 5,796.35. grams. Okay. Questions on that? Okay. Now, the next one I'm going to put up is going to involve that extra step with Avogadro's number. Okay, so you're going to be asked to calculate the number of moles. Okay, so number of molecules, sorry. So we're looking for the number of molecules of sodium sulfide in 29 grams. This is a number you're going to need. This is Avogadro's number. Okay, it'll always be supplied to you because it's on your formula sheet or the back of your periodic table. Okay, and it'll be on your unit exam. Right, so you don't have to memorize that number. Okay, it'll always be given to you. All right, so we're looking for the number of molecules of sodium sulfide. Remember that Avogadro's number is the number of molecules in 1 mole. Right? So give you a little bit of time to get ahead of me again here, and then we'll walk through that. So for this one, they want me to find the number of molecules. Okay? If I'm going to calculate the number of molecules, I'm going to need to know how many moles I have. Okay? Because I can use the number of moles and the number of molecules in 1 mole to figure out how many molecules I have. Okay? We talked about this the other day where I said, if you wanted to figure out how many donuts there would be in 2 dozen, you take 2 and you multiply it by how many there are in a dozen, 12, and you've got it. Well, we're doing the same thing here. Find the number of moles, multiply it by the number of molecules in a mole, and you've got your number of molecules. Everybody with me there? Okay, so that's what we've got to find here. All right, so the things we were told is, first off, that this stuff is sodium sulfide. Okay? So Na with S, it's an ionic compound that'll need to be dropped and swapped. +1, -2, so we're looking at Na2S. Okay, now I can calculate the molar mass, 22.99 times 2, so that's my 2 sodiums, okay, plus 32.06. What does it say on your guys? Is it 06? Yeah. It's 07 on yours, that's right, okay. All right, that's the one they changed. Just get it wrong. Okay, 32.07, so there's only 1 sulfur there, okay, and that'll get us our molar mass. So 22.99 plus 32.07 times 2. Okay, so we're looking at 87.13 grams per mole. Yep. I did, good eye. That one times 2 plus 32.07. Better, 78.05. Easy to make a mistake. Got to pay attention. I wasn't paying attention. Okay. All right, so we got big M, and they also tell us the mass, 29 grams. Okay. So can I calculate N right now? Okay. Even if I didn't know what to do with this question, if I have big M and little m, I can calculate N. I should probably do that, okay? At least I get some part marks, even if I didn't know what to do after that. At least I know I can go that far, okay? So N is going to equal little m over big M, just the mole equation, okay? That's going to be 29 grams divided by 78.05. Okay, I got a decimal, is that okay? Is it gonna be that kind of day? Feel like it. Okay, I got a decimal still. Is that okay? All right, just means I have less than a mole. And I do. I mean, I only have 29 grams. 29, not 29 grams, okay, and 1 mole is 78 grams. So yeah, I definitely have less than a mole. All right, so now I've got the number of moles, 0.37. I'm going to keep all those decimals in my calculator. I'm just not going to write them down on the board right now. And you need to do the same when you're doing these questions, okay? Always keep all of your decimals until the very end and then round. Okay, reason for that, I am going to multiply that number by this number, which is huge. And if I round it off, I lose a whole bunch of those numbers, and it can really affect my calculation. Okay, if I was only multiplying it by like 1.5, it probably wouldn't make as much difference. Okay, but I'm multiplying it by 6.02 times 10 to the 23. All those decimals are going to play a role. Okay, so I need to keep them all. Does everyone understand the justification for that? All right, so I'm going to take this, okay, and say the number of molecules equals n times halves number. Okay, and so in this case, that's going to be the 0.37 with all the other decimal places, multiplied by 6.02 times 10 to the 23. Okay, so I'm just taking that number, multiplying by Avogadro's number, which remember, we need to enclose in brackets when we put it in our calculator, 6.02. Okay, hit your exponent button, 23. All right, so I'm looking at 2.24 times 10 to the 23 molecules. Questions on that one? Okay, so this one would definitely be out of like at least 4 marks. So we're looking at a mark for your givens, okay? A mark for calculating the number of moles, okay? A mark for your math here on multiplying n by Avogadro's number, and a mark for your answer. All right, last one. Okay, it's the reverse of what we just did. This time you're being told the number of molecules. You need to get the number of moles from the number of molecules, and then use the mole equation to get the mass. Okay? All right, give you a couple minutes to try that one. So on this one of my givens is the number of molecules. Okay, 7.2 times 10 to the 23 molecules. All right, and they tell me that it is diphosphorus pentaoxide. 205. All right, so we're going to calculate the molar mass of that. We're going to have 30.97 times 2, okay, plus 16 times 5. So 30.97 times 2 plus 16 times 5. All right, 141.94 grams per mole. Okay, I'm supposed to find little m. In order to get little m, I need the number of moles. Okay, and I can use Avogadro's number and the number of molecules to get this, okay, as long as I understand that this is the number of molecules. Avogadro's number is the number of molecules in 1 mole. If I divide those two numbers, then I'll know the number of moles. Everybody okay with that? So n is going to equal then, okay, 7.2 times 10 to the 23 divided by 6.02 times 10 to the 23. Since they both have the same exponent, do I need to bother putting in the times 10 to the 23? I don't, okay? I can just divide the bases because the exponent's the same. Okay, if you understand math, okay, or that the exponents in math, you can do that shortcut. If you don't, it's fine to do it this way too, and just go 7.2 E23, okay, divided by 6.2 E23. You can only do this, whoops, if they have, and it's 6.02, if they have the same exponent. You can't do this if they don't have the same exponent. Okay, you would have to do it this way if the exponents don't match. All right, so I get 1.196, so 1.20. Okay, I'll write 1.196 for recap. Okay, so now I know the number of moles and I know the molar mass. So now I can go to this and get little m. Okay, but in order to get little m, I still have to manipulate this equation as well. Okay, so this is the longest or most involved of all the mole equation kind of questions. Okay, now that I've got that, now I can plug in those numbers. 141.94 times 1.196 is going to get me the mass. Okay, so we're going to have 169.76 grams. Okay, of diphosphorus pentaoxide. This would probably be a 5-mark question. Okay, you'd get a mark for your givens. Okay, you would get a mark for calculating the number of moles. Okay, you'd get a mark for the manipulation of the mole equation, a mark for your math, a mark for your final answer.
1.2 in your equation to find the mass, the answer still be correct if it's the answer you got?
No, that's why I said keep all your decimals until the very end. That's exactly why we have to do that, because it does make a difference. And I can't, if I round off early, I'm saying that these measured values that I've used to arrive at this number, they don't matter, or they're not as accurate as I measured them to be, and that's not true. And if I have a measured value, I need to maintain its accuracy until I'm at the end and going, okay, now I can round off. Now, it's something called significant digits, which we'll talk about later in the course. They help to maintain the accuracy of measured values. All right, any other questions on that? Okay, so now we've gone over 2 examples of each way that I can ask a mole equation question. Okay, we went over one of each way yesterday, another today. Okay, I'm going to do the same thing tomorrow, right? And then on Friday we're going to do our unit exam review, and Monday you write your exam. Okay, so what I'm going to have you do now is practice some of this stuff out of the digital workbook. Okay, so I'm going to show you which pages I want you working on. It's just doing some mole equation calculation type stuff. Okay. Okay, I want you guys to actually start with question number 2. Okay, so it's on the bottom of page 11. Okay, bottom of page 11 on the mole equation worksheet. Okay, so starting with question number 2. Okay, it's asking you to calculate the number of moles, so N, present in each of the following: 28 grams of sodium, 28 grams of iron. So these ones are even easier because you don't even get to compounds until D. Okay, so you're just looking for the atomic mass on the first 3, molar mass on this one and this one. Okay, and then number 3 is asking you to calculate mass. So it's, you got a few where you're calculating N, then a few where you're calculating little m. Okay, and then it gets into a few more realistic kind of problems. Right, so I want you working on those for now. Okay, I will post the keys on in the stream here while you're doing it. Okay, so you can check your answers as you go. Okay, I'm actually going to start with number 7. Okay, number 7 asks, which contains more atoms, a mole of iron or a mole of oxygen gas? And what I often have people tell me when they answer this question is, that's dumb. That's like asking which is heavier, a ton of feathers or a ton of bricks. They're the same, they're both a ton, except that this isn't. This isn't like a ton of feathers and a ton of bricks. Okay? And the reason for that is it's asking for the number of atoms. Okay? Now, in a mole of anything, there are 6.02 times 10 to the 23 particles. The difference is that iron exists as an element as a single atom. How does oxygen exist as an element? Which has more atoms, a mole of iron or a mole of oxygen? A mole of oxygen has more atoms, twice as many atoms. Okay? There are still 6.02 times 10 to the 23 molecules of oxygen in one mole. But each one of those molecules contains 2 atoms. Okay? So it's one of those questions you have to read really carefully, and you have to understand that there's a difference between an element that appears like most elements do as a single atom versus a molecular element, okay? Like oxygen or nitrogen or sulfur or phosphorus, okay? Or any of those ones that are highlighted on our periodic table. Okay? So a question like that could be a bit tricky if you got it on a test. Okay? It would maybe say something like, how many atoms are in a mole of oxygen gas or nitrogen gas or something like that. And you would have to remember that nitrogen gas is actually N2. Okay? Everybody follow me there? Okay. So that's kind of what question 6 is asking. How many oxygen atoms are in 64 grams of oxygen gas? So what do I use for the molar mass of oxygen gas? Do I use 16 or 32? Okay, 32 is the mass of oxygen gas. When I calculate the number of particles, though, what am I going to have to do? If I use 32, I'm calculating the number of O2 molecules. What does it want? Not divide by 2, you would multiply by 2. Okay? So what I'm doing here, guys, is if I want to calculate, first off, I'd have to calculate the number of moles, right? So N would equal mass over molar mass. So if I go 64 over 32, I'm going to get that there are 2 moles of oxygen gas, O2. Okay? Now, if I multiply that by 6.02 times 10 to the 23, I'm going to get the number of oxygen molecules because I used the molar mass of oxygen molecules. If I do this and I use 16, I'll get the right answer right off the bat because I'll be using the mass of oxygen atoms. Okay? And it'll end up being different. Okay? Everybody follow me there? Okay? It's a strange question. It doesn't come up very often, and the only reason I'm making a big deal out of it is I want you to understand the difference between an atom and a molecular element. Okay? A molecular element like oxygen or sulfur, okay, or nitrogen comes as a pair of atoms. Okay? And we have to remember that that's the way they come. They don't come as a single atom like most elements do. Okay? All right. I would like everybody to try right now 10B. Okay, I don't care where you are on the sheet right now. I want you to try 10B right now so we can kind of walk through it as another example here because we haven't done one together for a while. Okay, so for 10B here, if I want to get the number of molecules, okay, which is what this one is asking me to get, okay, what do I need to calculate first? The number of moles. Okay, I've got to get number of moles first, so I can multiply that by the number of molecules in a mole, Avogadro's number, okay, and calculate my total number of molecules. So, what are they giving me in this question? Okay, they're giving me N, 36.0, okay, moles. All right, well, how easy does that just make my life? Super easy, because I don't have to use the mole equation. They told me the number of moles. Okay? They told me the number of moles, so all I have to do is take the number of moles and multiply it by Avogadro's number. Okay? Number of molecules equals N times Av's number. Okay? We've done a couple of questions like that now. All right? So all I have to do is calculate this. Would it have mattered at all what material it was here? It wouldn't matter at all. Okay? This would be the same answer if it was sodium chloride. Okay? It wouldn't make any difference. This is, if I multiply moles by Avogadro's number, it doesn't matter what material it is, I'm going to get the same number. Okay? What the material influences is how many moles it would be if I knew the mass. In this case, they didn't bother telling me that. They just said, here's the number of moles, calculate the number of molecules, multiply by Avogadro's number. Okay? So that's really all we had to do, okay, was take that 36 and multiply by 6.02 times 10 to the 23, and we've got our answer. Okay, so all right, so I've got 2.17 times 10 to the 25. Molecules. All right, now here's something the question didn't ask. How many atoms are there in this number? Now it does matter what material I'm dealing with. Okay. I know I have 2.17 times 10 to the 25 SO3 molecules. I want to know how many atoms there are. How many atoms are in a molecule of SO3? 4. There's 3 oxygens and 1 sulfur. Okay? There's 4 atoms in that molecule. So what do I do with that number? That's the number of molecules. I just multiply it by 4. Okay? That would tell me the number of atoms that I would have. Okay? It's not something you're going to be asked to do very often, but it's still something we need to be able to look at a molecule and go, oh yeah, there's 4 atoms in that molecule. Okay? That's really what I'd be asked. All right, so everybody pack up, mask up, and I'll come around and spray off your desks and you can wipe them down.